So hi guys, uh, today we are going to discuss about the previous part of my video. It got stopped at the time. So today we'll continue from the Spark SQL engine where the end of the previous video has came. So it is been continued from there. Okay. So in this video we are going to cover all the rest of the concepts including this optimization systems and all, and my video is not supporting more than 2 hours and all. It is been stopped at that time, so let us please cover those concepts right now. So as we have discussed, what is Spark SQL engine? Spark SQL engine is a module. So it is what the definition. Okay. Spark SQL engine is a module in Apache Spark that process structured data. Whatever our structured data is there using SQL and data frame APIs. So whatever the code that we write, we used to write in either in SQL or in we used to write in data frames. Okay, data frame APIs. Data frame is kind of an API. Okay, API calls and all. Okay, so whatever the code that we write in SQL and as well as in data frames, so that thing, it it uses those two codes, and behind the Spark, behind Apache Spark, Spark SQL engine will be there. It just like as a Apache Spark uses Spark SQL engine as a tool to process our codes to perform our data processing at the last. Okay, so this is what the architecture. Okay, this is very important thing. So that's why I'm discussing this again, because in interviews also these questions will be asked frequently. So that's why I'm discussing this. Okay, so consider I'm a user. Okay, I have wrote my code in SQL and as well as in Python. Okay, good. What Spark does is Spark uses, I told, something called as Spark SQL engine. So this Spark SQL engine, it reads my either the SQL query that I have wrote or the data frame that I have wrote. Okay, but the thing over here is Spark directly uses our SQL codes. Directly it won't process my SQL code. Okay, whatever the SQL query that I write, it converts my SQL query into its own data frame. Okay, Spark SQL engine has something called as SQL reader kind of thing. Okay, it converts my code into my data frame, and this data frame will be gone to rest of the process. So whatever the code that I wrote, okay, there is something called as Catalyst Optimizer. This I have discussed in my previous class. This Catalyst Optimizer is used to prepare my logical plans, physical plans, and tags, all these things. So this Catalyst Optimizer will be performed. Whatever the transformations that I have wrote twice, and also it optimizes that. Okay, so it only prepares logical plans, physical plans, execution plans, everything. Okay, so what this catalyst optimizer will do, it immediately performs one logical plan for me. So this logical plan means everyone know it is an initial plan. So whatever my transformations I am writing, it just enters to that plan. So once all my transformations I have wrote, consider I have wrote so many filters and all, but those many filters are not required. Only one I can easily able to write it in one filter only. But as I'm not that much expert in Spark, I have wrote so many filters, so many things and all, which are unnecessary in the code. So those all unnecessary things will be optimized by Catalyst Optimizer, but there is no difference will be there in your code. See, whatever the code that you have wrote, you can visualize it normally only, but everything this will be done in the back end. Okay, so this will be converted into physical plan. Physical plan means, okay, now it is going to get executed like that. Okay, once physical plan is been designed, then it will go to the execution engine. What is this execution engine? This execution engine will this like how Spark SQL engine is there. There is something called as execution engine. These are all the components of the Spark SQL engine that I have discussed in my previous class. Like there is something called as tungsten engine will be there, execution engine will be there. There is something called as CCOPs will be there. So like that. What is this execution engine? This execution engine will helps to execute and processes whatever the plan which is being produced by the physical plans and all. Okay, and finally that I'll get the results. Okay, now this is the most important point that you guys need to understand, and these things this thing will be asked in the interviews also. What Spark SQL engine supports? Spark SQL engine supports both SQL queries and as well as data frame APIs. Okay. See, I told you there is something called as Spark SQL. Spark can read SQL also. See, you can't directly write select star from table. You need to write it within this spark.sql. So it used to convert your SQL into some data frames and all to execute. Okay, I hope this is the main what we call it as architecture of it. As I have told you, sorry, there are some what we call it as Spark SQL engine futures are there. Okay, what are the Spark SQL engine futures? The Spark SQL engine futures, the first future is this cost based optimization. Okay, cost based optimization. AQE. We are going to cover about this AQE in our further concepts and all. And see, every time we are turning off something called as AQE, na? So like that, we used to cover this in our future concepts. What is this one? And something called as predicate push down and column pruning. Okay, so these are the futures of the Spark SQL engine. What this cost-based optimization will do, see, there are, see, there is one below, there is one what we call it as flowchart is there. In that, you will understand what is this cost-based optimization. See, there are so many physical plans will be generated from one logical plan. Not only generate one physical plan from the one logical plan. It has so many physical plans. Like it used to apply this permutations, combinations, and this probability concepts. Like what could be the best plan like that. So how many possibilities are there? All the possibilities it will present it over there. So out of all the possibilities, Spark selects something. Spark uses something called as cost-based optimization, and it used to select only one plan out of it. That's where the use case of this cost-based optimization. Okay, that's it. AQ means adaptive query execution. See, adaptive query execution means every time whenever our Spark job runs, okay, Spark physical plans or plans will get decided during the runtime. Okay, when you run the job, then only after running the job, then only Spark decides it plan. Okay, but what AQ is a new feature that came recently. What it will do, it will changes your plan during the runtime also. Example, see, for suppose you have done one group by, okay, or you have applied one join. Everyone knows when you do some kind of y transformations and all, Spark defaultly creates 200 partitions for you, right? But would you use 200 partitions over there? No. Why? Why will not you use 200 partitions? Because out of 200 partitions, every time you can see almost we are using 3 to 4 partitions only. If I am doing it, okay, if I am doing it, 3 to 4 partitions only we are using. And rest of the 196 partitions are getting empty. Okay, so this is what the normal manner, normal physical plans that are going on. But what AQE will do? Okay, AQ will told, boss, do you need 200 partitions for your job? First of all, it analyzes our data sets. It analyzes how much GB of our data set is there. Okay, how much partitions it is required for suppose out of 200 partitions, my particular my particular data set needs only 10 partitions. That's it. Only the AQE will provide only those 10 partitions for you. It will not give you 200 partitions and you make all 190 partitions empty and let it waste it. No. It tells you, boss, why you need 200 partitions first of all. Your job will have only 10 partitions or whatever the data set you're having, it will take only 10 partitions. Why you are using 200 partitions? So that's why no, I won't give you those 200 partitions. So I'm changing your plan. I'm changing your what we call it as plan which you have wrote this y transformations. Only I'm allocating you those 10 partitions only. This is what AQE will do. Not only this one, it will changes our plan. See, for suppose if I wrote something in the code which is not required at that time, AQE will stop that. AQ told why you need these many things and all. It's just like as a security guard or something like that before. If you are taking anything wrongly, it will simply stop you and ask you why you are taking all those things. So that's why if you understood or not, while I'm performing joins, while I'm performing Y transformations and all, I have turned off this AQE. I think now you got understood why I have turned off this AQE, because if I won't turn off this AQE, na, it will not give me 200 partitions for sure. It will not at all give me 200 partitions. Okay, so that's why I make it off, and then I have run all my queries and all. Okay, and AQE will decide for suppose one more text case I'm giving. Consider I'm having two data sets. Okay, one table is very small table, one table is a very large table. Okay, you have applied a join and you didn't remember that I need to apply broadcast join for the small table. Okay, you have applied a join. If your AQ is turned off, okay, it will apply join. Generally how join will do, it will shuffle the data within the partitions and all. Once shuffling is been completed, then it will choose what kind of join I need to do, either it is sort merge join or anything like that, right? But if AQ is on, for suppose if you forgot to apply broadcast join also, because small tables we apply broadcast join only, why? The driver node will broadcast our joins and all, right? As I have discussed this in my previous class, and this class also there is one small concept will come called as broadcast variables. Okay, so when I have applied this, okay, what will happen immediately my AQE will say, okay, you forgot to apply broadcast join. No issues. I will apply for you. And it will apply what we call it as my broadcast join to my small table, and it will execute my query. Okay. So this is what adaptive query execution. So if I have applied normal join only. If I apply normal join, that becomes a sort merge join. Everyone know. But AQ will say why you want to apply sort merge join for having a one side very small table. I will apply broadcast join. Do not worry. And again, as I told, there is no change in your code. No change in your code in your notebook. It everything is done in backend. Okay. And second thing, third one, another feature of Spark SQL engine is predicate pushdown. Predicate pushdown is you you need to apply early filter. Okay, see, every time when you're reading your data, instead of reading entire data, better to apply filter, that's it. And that is also one of the future, the Spark applies auto filtering sometimes. Okay, to remove unnecessary things and all which are not required. And so you'll understand what is predicate push down. So what it will do, predicate push down, predicate means apply filter early filter. Okay, instead of, see, when you do group by without applying filters now, it will be a very big issue. Okay, because all the unnecessary values also will go into shufflings and all. Instead of doing that, if you filter your data, then you apply your Y transformations and all. See, narrow transformations, it is fine, but always you need to make in your head that you need to take Y transformations. Okay, fourth one, column pruning. Column pruning means nothing. See, if you are having some 21 columns in your 21 30 columns in your table. Okay, but you're reading only, if you want exactly, you want only 5 columns only to read. Out of those 30 columns, you want only 5 columns only to read. It is required to read select star from. It is required to keep select star from like that. No. Column pruning means what? You need to just apply what columns it is needed for you. That's it. You need to read what columns are needed for you. So that's why better to apply, select column names you need to put, what columns it is needed for you. Just take those columns only instead of spending money to read the entire data. Not only money, it will take time also. Okay. I hope these are the four major features of the Spark SQL engines. Keep it in your mind. Now, as I told, what this Spark SQL engine does actually. Okay. Let me explain. This is a very good flow chart. I am a user. I have submitted my code. What Spark SQL, what it is, what it will do, whatever the code that I have wrote, due to lazy evolution, it will add all my code into my unresolved logical plan. Okay, unresolved logical plan. So I have applied one filter, one group by, and one aggregation, and one more time I have applied filter also on top of it. Total four transformations I have applied. So what four transformations will be taken into this unresolved logical plan? Okay, once this is been taken, it uses something called as catalog analysis. Catalog analysis means I have told the catalyst optimizer, tungsten engines, all these things. It uses those things, and it will resolve. It will make my unresolved logical plan into resolved logical plan. Okay, or it is also called as it removes all the unnecessary things and all, and it pushes into my optimized logical plan. So here it is optimized completely. Okay, once this is been done, once this is been done, what Spark will do, Spark will create so many physical plans. Now only I have created three physical plans because of my space constraints and all. It will create so many physical plans. Why so many means, it will try to create physical plans in how many ways it is possible. Okay, like I can do like this. I can see what it can do means, see, morning you woke up and you do brush, bath and all. Morning you woke up, do brushing, go to have and tea, bath, and as well as eat breakfast. This is what your optimized plan consists of. How physical plans are made? The first physical plan can be, I can wake up, have a bed coffee, then go to brush, then go to breakfast, then this bathing and all. This is one physical plan. Sorry. What is the other physical plan? The other physical plan could be, I'll woke up, I'll take brush, take a bath, I'll take breakfast, then I'll take cup of tea. Second physical plan. What is the third physical plan? I'll wake up and first of all I'll what we call it as go to brush, and I'll go to where to take bath, tea, then I'll have breakfast. This is third physical plan. Like that, how many combinations are there in that plan? It try to give those many physical plans. Okay. Then what it will do, there is something called as cost model. This is a filter. Okay. It tries to filter all the physical plans, put all the physical plans within this cost model. And what this cost model will do, this will get one physical plan as an output. That is what the best physical plan. Okay. Now, this one blessed physical plan, this physical plan will be distributed to the executors via driver node, and that physical plan will be followed by the executors, and by that it will create partitions, by that it will create RDDs, all these things and all. It will happen like that. So this is what you need to understand. Okay. Now this is what entire concept of this Spark SQL engine, catalyst optimizers and all I have discussed in my previous class regarding my tungsten engines and all. If you haven't watched it, go and watch it over there. Now, we are going to discuss about how memory management will be done in Spark. Okay. What is this memory management? What are this data management and all mean? See, first of all, if I am writing my code, I'm writing my code means I'm writing my code, and as well as my data is there. There should be some space, there should be some space where it needs to store, right? See, I'm writing df dot some transformations and all. There should be some space where it needs to store, and this is very important concept that you need to know. Okay, because questions will be asked on this, and not only questions. If you want to what we call it as understand how memory management, how disk management will be done, you need to understand how Spark stores and all. Okay, so if I come to my Databricks. Okay, so this is my what we call it as my storage account. Okay, this is my storage account where I have stored something called as within my source container. I have stored my fee.csv and the students.csv files. Two CSV files I have stored. Fee consists of fee, student fee status and all. Student consists of student personal details and all. Okay, see, this is my external storage. External storage, or I can say one more thing, this is a disk. Okay. Databricks is not a place to store the data. Okay. Or Apache Spark is not a place to store the data. First of all, you need to understand that. Data will not be stored in Apache Spark. Okay. Okay, we can store, but there will be very limited amount of what we call it as GB or something will be given to you, and within that only you need to store, and you are storing it in memory. Okay, try to understand, memory is different, disk is different. Okay, let us understand how Databricks will pull the data from my disk. Okay, let me, I think somewhere I have wrote it. First of all, let me show that to you. Where it is there? Where? Yes, here. See, first of all, you need to understand this concept, okay? How my data will be pulled from the other storages and all, okay? First of all, disk means what? Disk is a permanent storage where your data will be reside permanently. Okay, memory is a place where your initial data will be stored, and why we are not storing in disk and directly, why we are pulling it to memory is, see, as I told, we have already what we call it as discussed one example called as memory. Consider Databricks, sorry, not Databricks. Your disk is a shelf where all your books consist of. Okay, if you want to take a book, and you know that your shelf consists of all kinds of books, starting from from 10th class to till your engineering, how many books are there? All books are there in the disk only, and that is a permanent storage. Okay, but if you want to take one book which you have read in second year of your engineering, see, if I have read something called as strength of mechanics, sorry, uh, not strength of mechanics, what we call it as, there is some subject called as, I am not remembering those things, moss, we call some subject called as moss. Okay, so if I want to take that book, it will take, if I go for, consider I am the user, if I want to, I am fetching for that book, if I go to disk, it will take some time for me to fetch that record. Okay, consider if I'm one book is there, if I'm using some book every time, almost all 2 to 3 days, every time I'm using that book. Okay, if I'm using that book 2 to 3 times, it is not recommended to store that book in disk. Why? Because it will take a lot of time, because there are so many books are there, you need to search from that book and you need to grab that one. Okay, that's why what you will do, wherever you are studying, okay, there will be one study table will be there, consider your study table as a memory for you. Okay, that study table memory, what you will do, you will keep that book on that study table. Okay, so it is easy for you to grab that book from the study table or memory. That's why we use. Okay, whenever you are what we call it as fetching the details and all, see, I am the user, I have wrote some query, and there are so many permanent storages are there. We'll store in Azure SQL DB, GitHub, data lake. Now I am using this data lake right now. Okay, this is my data lake. Okay, in the data lake I have stored my student and fee. I can store these things in server, I can store over here also. Something called as in my networks also. Okay, so these are so many areas are there where I'm storing my permanent storage. Okay, see, if I have wrote my code, okay, my code which I have wrote it in Databricks, we know within the Databricks Spark will be there. Okay, because you can't host Spark directly, it will take a lot of configurations and all. Instead of configure everything, write your code in Databricks will configure everything for you. What Databricks will do, Databricks will have one memory. This memory will go to your disk and try to get that memory to try to get the data from disk to memory, and it will hold it for some time for you, and then it will be what we call it as read from Databricks. Okay, this is not exactly, okay, it is not exactly, you will understand slowly what I mean to say. See, this is a disk. I'm talking about disk right now. Okay, so disk is a permanent storage. Okay, consider I'm using in data lake, so that's why I have only kept data lake, but there are so many are there where all my CSVs, JSON, Parquet files will be there. Okay, will be stored. And manage tables, some people know what are managed tables and all, you will understand in Databricks. Okay, persistent storage, that is one concept that we are covering in some time. Okay, now, how memory will be stored? Okay, how memory will be stored? First of all, I have given something called as df is equal to spark.read from the table of emp table, and I have given the path. The data will store in RAM for temporary for some time, and this RAM is used to process our data. That's it. Okay, and what it will do? It will go to my disk and it will load it into executors, which is my memory. Okay, from there it will process. How flow will be there? How flow will be there? Flow will be, consider this is my ADLS means data lake, Azure data lake system. It will read, first of all I am reading. Okay, it will load into the Spark executors, which is my memory. From disk to it will load into memory, and then it will whatever the transformations, like whatever the joins and all I have wrote it in my code, that will get executed once the data loads to memory. And finally I'll get the result out of it, and it will again write back those things to disk again. Okay, now if it is a managed table means Databricks managed table, that you will get to know in Databricks video and all. And Spark control, what Spark control will be done, like data is physically stored in the data lake, but it is pulled to memory, okay, before executing it. And from there it will execute the throughout this what we call it as these things. Even in our mobiles also same thing will happen. You are having 256 or 226 something called as additional GB will be there, that is disk. But additionally you will get 8 GB RAM and all. Okay, okay, but whatever the regularly you are using data like Instagram, Facebook, some YouTube, some PUBG games, you are, if you are playing anything like that, these things will not get from memory for you. Okay, it will just try to execute everything in this particular sorry, not memory, it will not take from fetch from disk and all. Okay, it will try to cover it up from your memory only, 8 GB RAM only. So that's why everyone will say try to get more RAM, because if memory only will helps to faster execute your processes and all. That's it. Okay, now, now, and what is cached data? Cached data, we'll discuss this concepts, do not worry. And let me scroll up. Let me scroll this where I am there. Now we are going to discuss about how memory management will be done in Spark. So before you have seen now what is a memory and all, and how memory managements will be done in Spark, and where our memory will be there, and how we are using those memories, and what kind of errors that we will get if our data won't process through our systems evenly. So we all discuss in this. This is very important concept. I have made it so simpler for you. So kindly please try to take notes and try to understand it. Okay, which is very much important. So if I go to my Databricks, okay, let us start. So we are going to cover about storage and as well as executors. Okay, what my in-memory storages will be there, and you can't see something called as some what of extra things will be there. See, you can see data read from the external file system. Okay, which is this month. External file system means what? From my disk, right? This is Apache Spark 2 now. Apache Spark 2. See, this I'm having within my memory only. Spark memory only I have uploaded within my volumes. Okay. If I have read the before DAG, na, the before DAG belongs to this file. Okay, new notebook, which I have read from the data lake, which is my disk. Okay. Now let me run the file which is there, the file which is there in my own memory. Okay. Let me run it because Databricks also have some space. So that space. So finally, I'm writing my data to my disk only. Okay. Finally, I'm writing my data to disk. Let me open my job. Let me open this one. Let me go to storage right now. Okay. So this is also having the data read from the external file systems only. See, which means Databricks having something called as the external file systems, where the data is reading from there. Okay, I think it is having some extra data and all. Okay, now what this volumes consist of? Let me go to my Databricks catalog and as well as system catalog, Spark schema, volumes, sample, sample. Okay, from where I'm reading my data, duplicate my notebook, recents. Let me go over here. Yeah, not this one, Apache Spark. See, this is a different file. Okay, and this is a different file. So that's why you can see the external file system, the data read from the external file system, it was changed. Okay, over here. Almost all it is having 1 MB, 1.4 MB like that. And this is having this very light data. So this is also having very light. Okay. There is no caches happen, nothing. You'll get to know what is cache and all. So this is about this we are going to discuss. Okay, in Databricks and all regarding storage. Okay. So without doing time waste, what we will do, we'll get back to our memory. So here we are going to discuss about the memory management in Spark. So there are two kinds of memory management in the Spark. Okay, what are those two kinds of memory management? As you know, the my Spark consists of drivers and executors. Cluster manager will not do anything. You know, cluster manager is kind of resource manager which will create driver nodes, and as per the driver node requirement, it creates executors and all. Okay, so there are two memories will be there. One is driver memory and as well as executor memory. When you create the compute, na, you will get to know driver memories and executor memories and all. If you select the if you're selecting the single node means both your driver memory and executor memory will be one memory only. Okay. Now, first of all, let us discuss about driver memory. It is very easy, but you need to pay attention a lot. As we know, the driver is a driver in Spark is a master process that coordinates all the tasks. Okay, what it does, it holds metadata. How many tasks are scheduling, it holds that one. It holds DAX and much more. Driver is not a location where you will hold your entire data. If you are having very large data and all, driver is not a suitable place to hold that everything. Okay. Driver memory allocated to driver and it process when the job runs. Okay, what is driver memory? There will be some memory will be allocated to the driver and it will process when your job runs. Okay, important. If driver memory runs out of memory is nothing but, for suppose if your driver is having 1 GB, consider 1 GB, you have loaded your data more than 1 GB to driver memory, then something called as out of memory error will comes. That's it. And we'll discuss this regarding this in detail. Okay. So job fails, out of memory error will come. Okay. Good. What components the driver memory consists of? Okay. My driver memory consists of two components. So there are two kinds of memories are there. One is driver memory, executor memory. Now we are going to discuss about the driver memory. Components of driver memory. There are two components are there in the driver memory. One is JVM heap memory and second one JVM overhead memory. Okay. JVM heap memory, overhead memory. Heap memory is a very core memory. Okay, not only in driver, executor memories also will having the JVM heap memory, which is a core memory. It holds all the important JVM tasks and all. Means what are the JVM related tasks are there, JVM heap memory will hold. Non JVM tasks, everything will be there, that will be held by the overhead memory. Okay, but before sorry, now before discussing it, JVM heap memory means it is a on heap memory. Okay, it is a very core memory, it is a very important memory in the Spark. Okay, it is a core memory area used by drivers JVMs. So Java virtual machine, JVM means Java virtual machines. So within the Java virtual machines only our code will run. Okay, it is basically what it is for, whatever the DAX that we create, not we create, driver node will create. It holds DAX, it holds metadata like storage plans, and as well as whatever our table metadata is. The table metadata means what? Data types. What are the table data types? How many columns are there? How many what we call it as constraints are there for that? All the additional data about the tables, or all the additional data about the storage, all the additional data about the what we call it as this RDDs also, RDD plans are also stored in this only. Okay, RDDs will be stored over here. What is this broadcast variables? Broadcast variables means, as we have discussed in our previous class, when I want to broadcast my what we call it as broadcast table, I told that the driver node will broadcast my table to the executors and all, right? The driver node will broadcast my tables to executors, right? To broadcast the table, we need to store it in a variable called as broadcast variables. Whatever the table data is there, That table data will be stored in a broadcast variable. This will be done in back end. We won't store that in a manual process. We just broadcast the table, but whatever that small table will be there, that will be stored in this broadcast variable, and this variable will be fitted in the executor's memory, and from there it will make joins and all. If you know about broadcast join, then only you could able to understand what is broadcast. It is a very simple concept only, okay? Nothing too much. And how many tasks got scheduled for me, that info will be stored over here. And collecting results and manage data. What is this collecting results? Collecting results means, see, when you collecting results means, just a second, let me tell you one thing. See, collecting results means nothing. This is your driver. This is your executor. You are having only one executor which has 4 cores. As you know, each core will take one partition. Okay. You read one data. Driver had prepared the RDD. For that, RDDs will do partitions. That partitions will send to the executor. Okay. Your data, RDD has prepared 4 partitions. Partition one, 2, 3, 4. Four partitions have done to executors. It had done the task. Every time when you give df.display, df.collect, df.show, df.take, this kind of action commands, what will happen means, see, whenever the user is requesting, okay, for suppose user is requesting to get some data, and finally he has done df.display. Okay, my partition A consists of, okay, my partition A consists of, okay, just a second, user 1 comma 2. Okay, partition 2 consists of 3 comma 4. Okay, partition 3 consists of 5 comma 6. Okay, partition 4 consists of uh, 5 comma 6, 7 comma 8. Okay, so I am the user. My data is having total 8 records are there. 8 records, 4 partitions will not happen until and unless you make it. Okay, now what you will do means, simply you have what we call it as prepare the RDD, everything. But when you click the df.display, df.collect, df.show, for suppose if you are if you have filtered the data and requesting for 1 and 2 records only. Okay, what if whenever you do df.display, so for suppose if you are requested for 1 and 2, 3 and 4 records only, this is a filter data. For suppose these two belongs to male categories, 1, 2, 3, 4 are males. Okay, 1, 2, 5, 6 are males. So you have done some filtering and you have fetched for male category, gender and all, and you want to fetch those records, and finally you have done df.display. When you do df.display, what it will do, what executor says, see, male category people are there in partition 1 and partition 3. These two people records will send to my driver node, and driver node will display it in the front end for you. This is what happens. If you could able to see the data in Databricks or somewhere after doing df.display means it nothing but how many executors are there which are there for you. If you are requested for the data, filter data or something, for suppose if you are requested for entire data, so all the partition data will be sent to my driver node. Okay, and this driver node will display for you, and as well as this collect also. Whenever you are doing df.collect means, see, there is lot of difference between df.display and df.collect. Df.display, if you have having some filtered data p1 and p3, okay, you want to get the data of some few people, okay, p1 and p3. If you do df dot display, only those partition details only sent to driver node. These two partitions will get ignored because these two partitions are female category. But when you do df dot collect, df dot collect means it will collect entire data from your executor, and these all partitions get collected and send it to the driver's memory. If your driver memory consider 1 GB and the partitions you have sent up to 2 GB and all, you will for sure get an OMM alert, which is out of memory alert, Java out of memory alert. Okay, this is what happens dot collect. Okay, so let us discuss in detail what happens. Okay, so these dot collect means it collects all the results and give it to the and managing manage. So this is what JVM heap memory will store, which is a core memory, which is very important. Okay, so it consists of DAX, it consists of metadata, broadcast variables, how many tasks are there, how many stages are there, what is their info. So these all things will be, it's just a team lead now, so it will not do actual work, but it will take the data from the team members or from the executors, what they're performing, all the data will be stored over here. Okay, now what is overhead memory? Overhead memory, as I have told, within the driver memory there are two kinds of memories there. One is JVM heap memory, which we have discussed before. There is one more thing is that the overhead memory. Overhead memory, simply it handles the non-JVM tasks. Okay, and you need to understand one thing. For suppose if your driver memory has 4 GB, your memory, so it will be written like that. You need, if you want to declare, you can declare like that. Say driver underscore memory 4G, driver memory overhead 1G. You can declare you how you want. Okay. Now, overhead memory is a kind of extra memory, but this is not to handle the JVM task. This is to handle the non-JVM tasks like JVM threads, shared libraries, off heap buffers and all. Okay, nothing much to discuss about it. Okay, because slowly you'll get to know what this non-JVM task once I show one flowchart for you. Okay. See, Spark needs extra memory outside. See, to perform non-JVM tasks, because every time you can't say that I will have only JVM kind of things and all like that. Sometimes you'll get non-JVM operations also. Okay, so at that time, extra memory from Java heap memory, because not everything runs inside JVM heap. Everything will not run. See, non JVM operations also will run over there. See, that's why I have told before, some operations are there. Okay, like Python, PySpark operations, JVM internal calls, df.collect, this one also. These are some of non-JVM operations. To store this memory, we use something called as JVM off heap memory. Simply was nothing much you need to remember. Overhead memory, heap memory is to perform all the JVM tasks. Okay, 90% of the task will be done in this. So that's why more amount of GB will be given to JVM heap memory. Overhead memory means it's an additional memory. That's it. See, this is what the architecture. See, and you need to understand whatever the Python process are there. For suppose you are writing a Python classes and all, these are all non-JVM, Java, not a Java virtual task machine tasks and all. Okay, so they also consume some space. Where it will be stored in heap memory, not heap memory, overhead memory. Okay, this is what the architecture you need to understand. Okay, what is this architecture? This is my Spark driver memory, or it is also called a JVM heap memory. This is my overhead memory. How it will be consumed? This is my driver node. This is my driver node. Okay, this is my driver node, which has two kinds of memory. One is Spark driver memory, and second one is overhead memory. Okay, this is a heap memory only. What this driver memory will have, whatever the data frames that I wrote, that one, metadata, DAG, plans, this as well as this stages, all these things. Okay, physical plans, logical plans, all these things will be stored over here. Tasks, jobs, everything. There are some of the tasks are there, like if you do df.take, df.collect, this is what broadcast, how it will do internally. Broadcast variable means cf.broadcast data, this will do internally. Core objects like Spark session and Spark contest, these things also we have discussed. These things also, all these things will be stored in the driver memory only. Okay. And if you do df.collect, any UDF function, so that's why Spark will not recommend you to do your UDF function. Spark every time say try to use the Spark built-in functions that I have given. Do not use your own Python functions and all. Okay. Spark every time used to prefer that. Okay. And one more thing, one more thing, one more thing. One more thing is, and Spark doesn't prefer to use pandas also. If you'll get to know why pandas should not be used in the distributed computing engines and all slowly. Okay. Now, and how my driver memory will be taken. If I'm having 10 GB, okay, if I have requested my Databricks or someone to give me 10 GB to my driver memory, okay, by default, 10 percentage of extra memory will be given to us as a overhead memory. We won't request for overhead memory. We request only for JVM heap memory only. Whenever I requested for 10 GB for my JVM heap memory, what Spark will do, it will give me 10% of my driver memory. 10% of 10 GB is 1 GB. Okay. 0.10 into 10 GB, which is 1 GB. So if I have requested 10 GB, Spark will give 1 GB extra for me. That 1 GB is extra is for my overhead memory. Okay. Overhead memory. So if I have requested, okay, 10 GB if I have requested, na, it has given me 10%. Na, okay. If I have requested 1 GB, if I have requested 1 GB for my driver memory, Spark will give me 384 MB extra. You can ask me like, Rohit, why? You told 10%, right? If I requested for 1 GB means I need to give 100 MB like that. Why it has given me 384 MB? Listen. See, first of all, the default extra amount of allocated to my overhead memory is 384 MB. It's a default. Okay. So whenever if I requested for 1 GB, obviously 10 percentage of 1 GB is 100 MB. It will say, boss, it is not required. My default is 384 MB. So whenever the 10 percentage of the driver memory is less than the default memory that got allocated to my overhead memory, so it will not take that one. It will take the default value and it will give me 384 MB. Okay. If I have requested for 2 GB also, what is the 10 percentage of 2 GB? What is the 10 percentage of the 2 GB? 200 MB, right? 200 MB is a 10 percentage of 2 GB. Then also it will give me 384 MB only. If I have requested 3 GB, what is the what we call it as 10 percentage of the 3 GB for me? 300 MB. Then also it will give me 384 MB only. When I have requested for 4 GB, 10 percentage of the 4 GB is 400 MB. Then it will take my 400 MB as a 10 percentage. Why it is greater than 384 MB. I hope you got it. And it will store like that. So whatever the code that I wrote and all the data frames, so all these things will be stored over here. And these plans will be given to the executors to execute next. Okay. Before going to the next one, first understand this. Okay. This I have told in the previous, not in previous classes, in our regular class interactions and all. But try to understand this once. Sorry. You will get to know what is the difference between non-JVM tasks. So JVM tasks and all, how our code will get converted. Just pay attention on this. Okay. So whenever I have submitted the code, there is something called as Spark session. Everyone knows Spark will create a section for you. Spark session or Spark context, Hive context, everything, right? These things cluster manager will be there. It will go to cluster manager. What cluster manager will do? Cluster manager will create a driver node for me. And again, what driver node will request what we call it as cluster manager to give me the what we call it as these many worker nodes are needed for me to request cluster manager again. Cluster manager again creates for suppose this driver node needs two executors or two worker nodes. It will give two worker nodes to two driver node. It allocates to driver node and it will leave. Okay. Here our cluster manager is our Databricks. Okay. Now let's concentrate on this project. Okay. This is my driver node. My driver node consists something called as application master container. Okay. This application master container consists of two major things, which is my Java main, JVM main, and as well as PySpark main. Basically, Spark is made to write my code in Scala or in Java. If I wrote my transformations, if I wrote my code in Scala and Java, directly it will go to my Java main and those things will get converted over here. Okay. But we are writing our code in PySpark, or we are using our Python functions, so Python classes, all these things. Right, I am using DF and as well as SQL, which is supported by Apache Spark. Right, but internally, whatever the PySpark code I am writing, it will store in PySpark main. And there is something, a bridge between them called as Py4j process. This is a bridge. Okay, whatever the code that I wrote in PySpark, that code will get converted to Java JVM processors and all by using this Py4j process. This is one of the interview question. If you are writing your code in PySpark and all, that will directly get converted to JVM mission, JVM process and all. We simply you can say no. There is something called as Py4j process will be there. That is a bridge between my PySpark coding and as well as the actual computation JVM process that will run backend. So it will go like that. So so whatever the code that I am writing, it will fall over here by using Py4j process. It will just go to JVM main. From JVM main, what it will do? It will send to my executors the code. Okay, this is entire my driver memory management, which will go over here. Okay, and 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 so these are my executors, right? See, when I do it, I have given over here. Why again this Python JVM is there? Why again Python one storage is been given over here? It is in executors. If I am writing my code in classes, objects, oops concepts, UDF functions, extra Python functions and all these things will be stored over here. So that's why Spark recommends you to write the code in its own Spark language functions, built-in functions and all. Not to use much, but we use. Okay, but we use. So that's why additional space has been given to that. Okay, so this is what the main thing that you need to understand. So when I give action commands, okay, when I give action commands, what are those action commands? So I read my data, so I have wrote it in DF. Okay, initially I have read one file. Okay, DF, within the DF I have wrote my file. So it will go and store in PySpark main. It will, my code will convert it to JVM process by using Py4j process. Once this is been done, it will send it to my executors. If within my code, if I have wrote any additional classes, Python class and all those things will be stored over here. If not, this executor will execute my read my file. Until and unless I give my action commands and all, it will not display to me because of this lazy evaluation process. When I have give this action commands like collect, display, show, Take means take n means if I want to take some n number of records, I can use df dot take. Df dot count, how many records are there? Df dot head of three means first three records, first four records, like that. There is no that much difference between take and head. Okay. Df dot write is also action command. Df dot read is also action command. Infer schema. If I give any of these action commands, the data will be taken over here, and this data will be sent to my driver memory. Okay. If for suppose if I do df dot collect or anything, both of my, for suppose my driver memory has, let's take 4 GB. Okay. If my one of my executors has 3 GB, okay, and this I'm having something called as 1 GB. 1 GB. If I read these two files, total how much GB I'm having? 4 GB. Right? 4 GB. Sorry, 4 GB. Not 4 GB, 3 GB. Let me take something called as 2 GB. Okay. Total how much it is there for me? 5 GB. So if I give df dot collect means what will happen? It will collect all the data from both of my executors, and this 5 GB will be given to my executor's memory. Can it handle? No, because it is having only 4 GB of data. So it can't handle. Then there will be one error called as executor out of memory alert will come. This is what, sorry, driver out of memory error will come. Okay, this is what you need to understand. What this driver out of memory? See, the driver is a it's a driver's heap memory error. Why? Because everything it tries to store in driver heap memory only. Okay. If memory is unavailable to process by driver, then OMM will come. Okay, so what? How much amount of memory or how much amount of GB or how much amount of data that is come from my executors? If my driver unable to process it, then OMM alert will come. Simply, what will happen? It will crash. Okay, this is what the definition. Driver OMM occurs when the Spark driver process exceeds its memory limits. Okay, typically due to collecting large data sets, using pandas, broadcasting large data sets. Small spelling mistake. Huh? Broad, broadcasting. Okay, broadcasting huge amount of data sets. Okay, why using pandas means, see, pandas, there is a lot of difference between pandas and as well as our Spice Spark. Both are same only. Okay, both uses data frames, both will process the big data only, but only one problem is there. Pandas will work on single mission only. As our PySpark will create so many worker nodes, so many missions, and it will try to execute my code in a distributed computing manner, but pandas will not support that. How much amount of data that you want to process, pandas will say, boss, process it in single mission only. So that's why pandas is eligible to clean the data or process the data or transform the data within a single mission only. So this is one of the question that will be asked in interview. So that's why I have mentioned pandas over here. Why I can't use pandas? Pandas is free now for me to use. Yeah, it is free, but it will work only in single mission. You can't distribute the data throughout multiple missions to process it. Okay, so that's why there will be no clusters, nothing will be there in pandas. So if you are having 10 GB of data, process it in one mission and give me the result. If you are processing that much amount of, for suppose if you are getting the data from pandas, okay, definitely you will, if you are converting your code to pandas, you want to process it in one mission, means all the data from all the missions will get collected and it will give me, for suppose if you are having four what we call as executors, four executors, each executor having 2222 GB. So how much now, how much amount of GB will be having out of four executors? 8 GB. If you are converting all your data and converting into a Panda data frame, then what it will do, df.pandas, if you are doing like that, the data will get collected in from all the executors, and what it will do, 8 GB to 2 into 4, total 8 GB of data will be there in one particular data frame only, and that one particular data frame will send to my driver node, which causes OMM alert. If your driver node is having 16 GB, 20 GB, it's okay. But that is not an efficient manner. Okay. So that's why it can be avoided by keeping data processing on executors and limiting the data transfer to the driver. So that's why we should not transfer so much amount of data to my driver. That is the first rule you need to keep it in your mind. So the rule is never pull big data to your driver, because driver we maintain a bit of smaller amount of memory only. We should not get that one. Okay, so this is what the error you can see. This error, you, so many people who are working on servers also, they could able to identify this error, java lang out of memory error. A java lang out of memory error means when you are having memory got exceeds because of this memory with some data or anything or some heap dump files, at that time only you can see this error. So in our Spark, if my what we call it as driver's memory cannot process the what we call it as data that came from executors, or my memory that came from executors has crossed my driver's memory GB and all, at that time this error will come. What are the symptoms are there? Why it comes like that? Symptoms means, first of all, if you are using df.collect, this is the most common error so many people will do. If you are having huge amount of data and all, when you do df.color, entire data will come to driver. Second thing, df to pandas. To pandas means what? You are converting your entire code to pandas. Just now I have discussed before. What Spark data frame will do? Spark data where will convert to pandas data frame, and that will be sent to driver. And as I told, Panda is not a distributed engine, it works on single mission only. Okay, so all the things will go to single missions only. It creates an error. When you are doing df.display, this is every time you do df.display. Na, see, if I'm having large data sets, large means bigger data sets. If you have read the data frame of a big file, that's fine. But if you have done df.display, if your file consists of 1 lakh records and all, what it will do, it will collect those things and try to send it to driver node. All the executors data will fall on driver memory only. It causes errors. Large broadcast variables, as I told, if you want to broadcast a table, it should be a very smaller table. Otherwise, do not broadcast it. Simply go and apply sort match join. Okay. If you are trying to broadcast large data in a broadcasting and all, broadcast variables also, first of all, these broadcast variables store in driver only. Okay, because when you do df dot broadcast, when you write it, this table will be stored within this data will be stored within a variable which is a broadcast variable. Within that broadcast variable, this table will then it will get broadcasted to different executors and all. So if your broadcasted table is very huge table, then it couldn't able to manage that one also. Writing custom logics. Custom logic means what? Heavy Python logics and all, which which consumes more amount of data. If you are writing huge amount of code which you are having more amount of data, then this error will come. And driver is temporarily unavailable due to high memory usage. Okay, this kind of in Databricks you can see this error. Okay, simply it will throw an error, driver is temporarily unavailable due to high memory usage. Okay, not only this time, how many times if your executors is throwing or partitions which are throwing huge amount of uh, GB to your driver which exceeding the driver's memory, then every time this error will come. The notebook will be automatically reattached. Okay, these are the symptoms. Okay, what is a fix to do the OMM error? Simply, you can say, everyone will say increase your driver memory, but this is a temporary solution. Why? Every time, how many times, for suppose your data is going or rapidly increasing day by day, day by day, day by day, day by day, and all. How many times you keep on go to your cluster, edit, keep on increasing your driver memory and all, which costs huge amount. You need to think logically. This is a temporary solution only. Okay. If you know that, okay, after this much amount of data, I won't get more amount, then only you can simply increase your driver memory. Otherwise, what you need to do, instead of doing collect you can use for smaller data frames and all, or filtered data, which is very minor data only. Okay, minor memory of data. If it goes to driver also, nothing will happen like that. You need to do collect for those things. Take, display for see, that's why it is told avoid using collect, take, display, show for larger data sets. You should not do that one. Avoid two pandas on larger data frames. Do not do at all two pandas. Okay, if data is equal df.collect, Python processing only. Okay, now what is a broadcast variable? Okay, this one only I have explained before, but both are having similar comparison, so that's why I have told that. See, a broadcast variable is a read only shared variable. This we can't apply any kind of transformations on this broadcast variable, so that's why it told read only shared variable that is created on the driver, which is created on the driver. See, if I have created broadcast underscore var, so this is a variable within this only smaller data set will form. Okay, distributed to all and it will be distributed to all the executors so that it can reused efficiently across the task without sending it multiple times. Okay, without shufflings and all. Why we use broadcast variables and all? Because to perform the broadcast joins, if you write broadcast of that particular column, immediately it creates one broadcast variable, and within that broadcast variable, whatever the broadcasted column that you have wrote in your code, that will be stored over here, and this variable will be sent to my executors, and it will set in my executor memory. So whenever the partitions are there, it will go and get from my executor memory, which is very easy to make join instead of doing shuffling. Yesterday we have discussed about the broadcast join. So this is what about broadcast variable. Now, this is what all about driver memory management. So why OMM alert will come in driver means you are now capable to tell, because of whenever we do df dot collect all these things and all this thing, driver memory management will come. We should not give much pressure to driver. You can do collect and all for smaller data sets. Okay, this is what you need to understand first. Okay, now the second one. So I have told there are two kinds of memories are there. One is driver memory, second one is executor memory. Driver memory, within the two kinds of there, JVM heap memory is there, and second one is this what do you overhead memory. Overhead memory, you do not take much pressure and all. Whatever your additional non-JVM tasks are there, that will be stored in the overhead memory. In heap memory, only the JVM core tasks will be stored in that. Okay. Now, the second type is executors memory. Executors memory means what? We are talking about this memory. What this holds? It holds all the partitions, everything. Now we are talking about this memory right now. We have discussed about the driver memory. Now we are going to talk about the executors memory. What components that executor memory have? Executor memory have mainly four components. JVM heap memory, this is same exact replica as my driver memory. Okay, it is very important. This is a core memory, you know that one. Off heap memory, this one also you know. This will not be managed by this one. So there is something called as off heap memory. Off heap memory means this is extra memory that will be given. This is not overhead memory. Okay, overhead memory is the before one that we have discussed. This is something called off heap memory. extra it will be given. Okay, defaultly it will be 0, and it will not be managed by the JVM. Okay, it will not be managed by the JVM. Okay, we need to declare if I want. Okay, overhead memory, same like as before, driver memory only. Okay, it will take non-JVM tasks and all. It will handle those tasks. By default, 10 percentage of the total executor memory will be given to the overhead memory. And PySpark memory, default 0. Whatever the PySpark coding, whatever the things that I am writing, that will be stored over here. Okay, now what my executor memory really consists of, what it will store, we'll discuss. Okay, so let us continue. So we have discussed about how this executor memory management will be done, and now let us discuss about what, see, we, as I have explained just now, this executor memory has something called as JVM heap memory, which is very important memory that you need to understand, and as well as JVM hop off heap memory. Okay, this is something new. Yeah, sorry. So this is JVM off heap memory, which is something called as additional memory that was granted to you, and it is set default 0. Okay, and it will not be managed by JVM at all. Okay, so let's keep it aside. And overhead memory, as we have discussed in driver memory management, it is exactly same. Okay, it's exactly same replica of it. Okay, now this will take 10 percentage of your total executor memory. Okay, and as well as there is one more memory is been granted for you, that is PySpark memory, which is also set defaultly 0. If you want, you can add it. If you do not want it, you can skip these both. Okay, here the most important thing is JVM heap memory and as well as overhead memory. But we are going to discuss about JVM heap memory only, because there are so many components are there which is there JVM heap memory. So if I go to my driver memory, you can see only two components are there, which is my Spark driver memory and as well as Spark driver overhead memory, right? There are only two components are there. But if you come to JVM heap memory in this particular executor memory, there are so many components are there. Okay, before discussing about those, let us understand what we can store in our driver memory and all. Okay, in executor memory only consists of, see, whatever the data, as I told, the executor memory will fetch the data from the data lake initially and stores over there, and that data will be given to the data bricks, right? So what are the actual data will be there which got fetched from the data lake databases, all these things will be there in that. So, and as well as partitions of the data frames also, the partitions which was made by RDDs and all those partition data frames also stored in the executor memory only, and all these executions will be performed here. Okay, as well as if you have done having any shuffle data, when shuffle data will come, if you are having any joins, if you have performed any group by transformations and all, so all these are intermediate data or partition data. Intermediate data means what? If you have done any filtering, okay, you will get some different data na? Like if you are having some five columns are there. Okay, if you take five columns and out of five columns you are having some consisting 200 records. Okay, in the 200 records there are two kinds of genders are there, male and female. You have done one applied one filter operation and you have just filtered all the male categories. Male categories are 100. Okay, out of 200 rows you have filtered out 100 rows. Okay, and where that 100 rows filtered, documents will be stored, and where that 100 intermediate results will be stored, those results also stored in this particular memory executors only. This is what also we call as shuffle data. And if you have done any group by, you will get some different results. If you have done some any aggregations and all, there also you will get some different results and all. And if you have only fetched your partition data, then also you'll get some different results. So where those all results will be stored over here only. Okay, as well as execution memory. What is this execution memories and all? So there are two kinds of memories which are available that we will discuss. Execution memory consists of join, sorting, aggregation, all the intermediate results. Storage memory consists of cache and persist. This thing also we'll discuss. But I will, okay, we'll discuss, okay, once we get over there. Next, come down. And as well as one more thing, as I have told that if you are applying any broadcast join, the driver node will create one broadcast variable, and that broadcast variable, it will store the smaller data set, and that broadcast variable will be broadcasted towards the executors. If you are having two executors, within the two executors it will broadcast, and I have told it will fit easily in the executor's memory. So this broadcasted data copy also will be sit in this only. So the small table which comes from the driver, that's it. Okay, now leave about all these things, okay, because these all are additional data sets only. Okay, like off heap memory, overhead memory, PySpark memory and all. Okay, overhead memory is required, but off heap memory and as well as PySpark memory you can ignore. Why? Because if you want, then only you will create it. Just main concentration you need to put on this JVM heap memory only. Okay, now come down. So what this JVM heap memory consists of? Okay, JVM heap memory consists of. As if you have seen in driver, there are only two components are there. One is heap memory and this one. And there are no components are there in heap memory also. Heap memory is just a normal memory. But it's not like same as in the executor memory. Okay. In executor heap memory, there are four components are there on top of it. Okay, so this is what completely of JVM heap memory. This is what JVM heap memory. Okay, and as well as this is a overhead memory. Now let us see how calculation goes and how if you have requested for some GB of data, how the data memory gets splitted each other, and it will say you will get this much, you will get this much, like that. Okay, so this is what the executor memory, or you can say heap memory, executor heap memory, which is defined as spark.executor.memory, which is a heap memory. Okay, on top of it you can see spark.executor overhead memory will be there. Okay, what heap memory is having? For suppose if you have requested for 10 GB of heap memory, you know that it will get 10 percentage of executor memory to the overhead memory, which will give one extra GB for you. Total you will get 11 GB. This you know in driver memory management only. But when it comes to heap memory, this got splitted into three components over here. One is reserved memory, the other one is Spark pool memory, the other one is user memory. Okay, there are no splittings in driver memory management. Okay, but in when comes to executor memory management, the JVM heap memory will get splitted into three main components, that is reserved memory and as well as Spark pool memory, and other one is user memory. Okay, what this reserved memory means? Reserved memory is by default it will have 300 MB. Okay, by default it will have, not by default, it is reserved. Okay, it will have 300 MB. Okay, and as well as what is this Spark pool memory and as well as user memory. Okay, this Spark pool memory is very main. Okay, which is used for transformations means if you applied any group by and all, and if you are having any cached data I will explain you, this is very important concept also. And this Spark pool memory by single-handedly it will hold 60 percentage of the total executor memory. Okay, and user memory will hold 40 percentage. Okay, what is this means? As I told, this reserved memory will hold 300 MB. This reserved memory is used by the Spark SQL engine. That's it. Because it needs to analyze the logical plans, it needs to provide the physical plans, and also it needs some amount of memory. So that's why it is a reserved memory which is used by Spark SQL engine. That's it. Spark engine. That's it. Okay. And it's a fixed amount. No one can change it. You can do alterations within these two, Spark pool memory and as well as user memory. These are also consider you have requested for what we call it as 10 GB in this. 10 GB, as I told you have requested for 10 GB, right? So 10 GB, if it is Spark pool memory is taking 60 percentage, if I do 60 by 100, you will get 0.60, right? You need to do 0.60 multiplied by 10 GB of your data, and you need to remove this particular 300 MB which is reserved. Okay, so you will get 5 GB of data which got allocated to your Spark pool memory. And when it comes to your user memory, the remaining will be used by user memory only. What is this UDF? See, for suppose if you have done any some Python UDF functions, and if you have used some Python classes, OOPS classes and all, so those all UDF functions, it needs to get allocated or it needs to get stored in a different place. That is what is called as user memory. It will get allocated 40%. How it will do? 0.40 into 10 minus 0.3. 10 means what? This is the 10 GB that you have requested for Spark to allocate this amount of memory to my executors, right? It you will get something called as 4.5 like that. Okay, and it is just like as a base calculation I'm doing over here, but this is how it does calculation. Okay, I hope you understood about how this executor memory having how many components are there and how it distributes the requested data within itself. Okay, we need to majorly concentrate on this Spark pool memory, which is very important, which we are going to discuss next. Okay, this Spark pool memory is got furtherly, it got what we got split it into two major parts. Okay, this Spark pool memory consists of storage memory and as well as executors memory. This is very important thing. See, the most of the people will not ask questions on this. Okay, what is reserved memory? They will ask, but not that much. Okay, they will ask majorly. They will ask questions on this Spark pool memory also. What executors memory having means you need to say within that executors memory we are having three kinds of memory. Is there reserved memory, Spark pool memory, and user memory? And you can say reserved memory has 300 MB and Spark pool memory uses 60 percentage of the total executor memory, and as well as user memory will use the 40 percentage of the total executor memory. You can say like that, but you need to mention one more thing, what components are having in the Spark pool memory, because all the transformations and cache data, that whatever the operations that we are performing, all those data will be stored in the Spark pool memory only. Okay, now when coming to this Spark pool memory, we are having consider, okay, as I told, we have got 5 GB out of total executor memory as per the 60 percentage calculation, right? Now, if you come down, you can see that there are two components are there in this Spark pool memory. One is storage memory. Remember these points. Second one is executor memory. Okay. Storage memory is used for caching, persistency. Storage memory is something called as long-term memory. Okay, it use this memory, it stores whatever the data that you are storing over it. If you are storing anything in storage memory means it is a long term memory, it holds your data for long term. Okay, we store our data that can be referred later in the code. Okay, and as well as I told, memory means what? It will when till your operation is getting executed, till then it will store your memory. Okay, it stores your data. Once your operation get completed, or once you have what we call turn off your section, or if you go out, okay, at that time what will happen? It will just clears the memory. That is what the memory principle, right? Now, in the storage memory, what it will do, whatever the data that you are using, right, it will store for long term period. Executor memory means it will store your data for short term period. For example, if you are performing any group wise, if you are performing any count, if you are performing any aggregations or any kind of transformations and all, filter, all those things will be stored in the short term memory only, which is the executor memory. Because how many transformations it will store? It will process your data, it will store while your notebook runs or while you're doing the transformations and all. Once it gets completed, it needs to clear that space, because if not, there are so many notebooks will be there, there are so many transformations it needs to run. How many it will store like that, keep on storing all the transformations and all? No. Executor memory is a short term memory, it will be there for some time only. But storage memory you will store for long period. So this point you need to make your mind clear. And one more thing is, there is something called as what we can say, Spark memory storage fraction. Okay, this is the most important thing. This got been applied after Spark 2 plus, I think so, version. What happened is, before Spark 2 plus, okay, Spark memory got strictly allocated to 50% storage memory need to have, 50% executor memory need to have. That's it. There is no any change in between that. It's strict plan. Okay, you need to follow. For suppose if my executor memory is full, okay, because every time our executor's memory only gets full. Why? Because all the transformations and all, if you are having so many transformations, this will get full. And storage memory, for suppose if you are not caching anything, if you are not doing any persistence of your work, this will be empty. So if my 200 GB got crossed from executor memory, and now if my 200 GB got crossed from my executor memory, and the storage memory is very light, okay, it's not there, even 1 GB also didn't filled up. So there are a lot of data is there, lot of GB is there. Can I use it? No. Before Spark 2 plus, before Spark 2 plus, we are not unable to use this one because it got strictly divided like that. Later on, what happened? There is one concept came as Spark memory dot storage fraction. So they have kept one layer, na, this one, this layer. This is not the fixed layer. This can be changed dynamically. Okay, this can be changed dynamically, and we will discuss about it also. What this Spark memory storage fraction will do, we can, for suppose if my executor memory, whatever how many transformations are taking memory for me, if suppose it crossed 2.5 GB, and for suppose it had taken 3 GB, okay, 500 extra MB got taken. In that situation, I can dynamically move this upwards over here, and I can consume the data from the storage memory, empty spaces of the storage memory. Okay, we'll discuss about it, no issue. Let us take one small example here. Okay, if for suppose my executor is having 8 GB, consider my executor is having 8 GB executor memory I have requested, and within the executor, I, for my Spark pool memory, I got 8 GB. Okay, it's not like entire executor memory. After giving to reserved memory, user memory, and as well as overhead memories and all, everything to, after splitting to every all the components, within my Spark pool memory has got 8 GB. As before, what happens before Spark 2 plus, executor memory will take 50 percentage, storage memory will take 50 percentage. Okay, what executor memory consists of? My joins, sort. Sorting means if I sort anything, if I do aggregations, all the shuffle operations that I do, all that memory will be consumed from the executor memory only. As I have told now, shuffle is a very costly transformation and all. Why? Because it consumes a lot of memory. Because it needs to shuffle within 200 partitions of my, actually it will not shuffle till 200 partitions, but it needs to shuffle the data which cost a lot of memory from this. Okay, and why we use this complete executor memory for our computation? Only for our transformation purpose only we use our executor memory. What for storage memory? Storage memory will have cached data, persist data. You with this concept, just 2 minutes this concept will come. Okay, you'll get to know what is caching and what is persisting. Broadcast variables, I told now, this particular driver memory will broadcast the broadcast variable to the executors. That broadcast variables will be stored in the storage memory only, because those broadcast variables should be there for long term. So it should be stored in the long term memory. Okay, it's not like once I have performed transformations and all, it needs to get cleared out of it. No, it's not like that. So to store the data in the memory, so these things will be stored over there. Now, as I have told, this Spark memory storage fraction, this line, we are going to discuss about this line. Okay, what is this line mean? Simply, see, it defines how much portion of memory we need to reserve for the storage memory. So it decides, okay, how much amount of what we call it as portion we need to give to storage memory, and as well as for the executor's memory. Here, one more major thing you need to understand is executor's memory is our first prior thing. Second prior thing is our storage memory. Make this point in your mind. Okay, executor's memory is our first major concentration. The second major concentration is our storage memory. Okay, and how you will set this configuration means, I told you, you can change it dynamically. You need to write spark.conf.set spark.memory of storage fraction. If you give 0.5, it will give half of. Okay, if you give 0.4, the 40 percentage will go to storage memory, 60 percentage will go to executor's memory. I hope it's clear, right? Now, I told her there is a strict separation between Spark 1 version and as well as like that, like 50-50 should be there like that. But Spark 2 has came something called as I told her, you can change it dynamically like that. Like you can change this line and all. That changing dynamically thing is called as unified memory model. Simply, if you want to change your spark fraction line, and if you want to allocate the spaces as you want, like executor, because executor memory is not using this much, so give 10 percentage from the storage memory and all like that. So if you are using like that, it is what we call as unified memory model. This thing also we'll discuss furtherly, like coming topics and all. This is very important also. And one more thing, if storage is not used, what this what we call it as unified memory model will do, if storage what we call as memory is not used, execution will take that memory and it will use for its purpose. If execution memory gets full, then only it will go over there. Okay, if execution is free, okay, if storage is having means execution is very less, and if you have done lot of caching persisting in your storage memory, then it will get expanded. So if it wants to dynamically expand it and use it, that is what we call as unified memory management. Now the concept called as caching and persisting came. As we are discussing in storage memory, we use for storage memory for caching and persisting, and what is that actually? Okay, caching is nothing, boss. Okay, example, it stores data frame in the memory. So for suppose if you are writing any data frame, it stores your data frame in the memory, where in storage memory, to avoid recomputation. What is this recomputation? Okay, and store cache stores data in memory to avoid recomputation. What is this recomputation mean? See, let me tell you. You have read one file. Okay, you have read one file. What spark dot read some employees dot csv. Okay, and after that, what you have done? You have created one more data frame, I sal df. And within this one, what you have done, you have filtered out the employees whose salary is greater than 5,000. Okay, here how many transformations you have applied? Two transformations. One transformation is to read the data, and one more transformation is to filter out the data. And what this DF data frame consists of? DF data frame consists of all the employees records. And what this high sal data this data frame consists of? It consists of the filtered employees whose salary is greater than 5,000, right? For suppose after that, again I have used this high sal DF so many times. I have used this high sal DF for so many times. First of all, I have done count how many people are there. Again, I have used this high sal DF to select only name of those employees. And again, I have used this high sal DF to do group by with respect to departments and count. Okay, for suppose if I am using my same data frame for multiple times, what Spark does internally is every time it reads this file again and again, means every time it applies filter on top of it. Every time it applies filter means every time this data frame will run for each and every time you are using that data frame. For suppose if you are using once, again it will read, again it will read this data frame, and then it will perform this operation. Again if you are using the high sal df, again it goes over there, reruns this data frame, whatever the result it will get. Why? Because it's a short term memory, right? Because it is an executor memory simply, right? Executor memory, once the operation will be performed, it's done, it's gone, right? Again it will, what it will do, again if you want to do group by with the high sal, again it will run, and it will take that data frame result over here, and again it will store. Because it's a executor memory. Executor memory needs to have short term memory. Once the operation is done, that's it will clear it, and it goes to the next operation. Okay, if again reading file reading again and if needs to file, if it needs to filter this one, it needs to filter from the df also doesn't know anything. What it will do, again it will read the entire file. For small files, 1,000, 2,000, 10,000 records, it's fine. If you are having some 70,000 records, 1 lakh records like that, again if this is what we call as recomputation. Means if, but you can't see it virtually, okay? You can't see this virtually. What you can see in the code, like in the output that I'll show, whether it is performing recomputation or not, okay? This is very easy to understand also, okay? First of all, if this one is done, you are doing count, again it reading this one, and it will say, boss, I don't have df result, I need to read the file. It will again go to file, perform this one first, then perform this, then it will read this one. See how much memory it is taking from the executor's memory. This may lead to get executor omm also. Okay, so that's why what we are doing, we are applying something called as caching. So what this will do, it will read file again, it will filter again, it will execute the full pipeline again. So waste of time and resources. Okay, what is the solution for this, Rohit? Means we'll do simply called as caching. For suppose once I have read my file, okay, on high sal df, what I have done, df dot filter salary, who I want the employee salary who is greater than 5,000. At the end, just I will write dot cash. If I write dot cash means what it will do, it will pick my entire data frame result, okay, and that result will be stored in my memory, where in storage memory. That's why I told it's a long-term memory. It will not clear even if you next move to the next transformation also. That's why it is called as long-term memory. Okay. I think you're now connecting with the points and all, right? Now, high sal DF means if you are taking high sal DF, this filtered data, whatever this filtered data is there, this data will be get cached and stores in the filter, in the, sorry, storage memory. Okay, so it will get to file and it will filter it, it will read the file, it will filter it, and this data will be stored in the storage memory, not in executor's memory. Executor's memory is a short-term memory. Storage memory is a long-term memory, stored memory. And furtherly, if you are doing like high sal dot count and all, right? Furtherly, if you are doing df dot count, it will not again recompute this dfs, two dfs. It will not recompute this one. It will not read the file again. It will not apply filter again. It will just go to your storage memory and it will pick the saved file cached data which is there in your storage memory, and it will read from there directly. So here recomputation will not happen. So memory consumption will be very less. So if anyone asks why you do caching and persisting and all, because to prevent the executor's memory, and instead of recomputing the transformations again and again, we just cache it that data and store in the storage memory. That's it. This is what the major reason that we'll do. And what it will do right now, it's reading from the memory directly. It will read from memory directly instead of recomputing again and again. So the next operations when you are doing, it will not fetch these things. It will just directly do this one. Okay, so this is what the main things of caching. Now, what is persistence? What is persistence? So, what is this persistence? Okay, see, persistence, cache are almost all same. Okay, but persistence is a bit advanced to what we call it as cache. That's it. Okay, persistence can decide where I can store my cached data, persistent data, or broadcast variables, whatever the things are there. Okay, cache can store the this what we call as cached data or this broadcast variables in memory only. Okay, but persistence can store my data in my memory and then disk also. Disk means what in our data lake where you are using your permanent storage, as we have discussed before. Disk means your permanent storage location where the data will not go anywhere. The data will reside at that place only. Okay, this is what persistence majorly, but we'll go in depth. Okay, so what it is telling right now, it is advanced to cache, advanced to cache. So what we can control the storage and stored cache data in memory or in disk. It's our wish. For suppose if your memory is getting full, you can store it in disk also. That's your wish. How you will decide that? How you will decide that? Based upon these three options. Okay. Based upon these three options, you will decide. First of all, you need to do from PySpark import storage level. This is the thing that you need to first import from PySpark import storage level. You need to import the storage level. Okay, means where this is what the storage level. And if you do df.persist storage level dot memory and disk. Okay, mostly we use this memory and disk only. Okay, if I'm using df.persist storage memory and disk means I'm just telling to my Databricks or I'm just telling to my Apache Spark, if my storage got full in memory, simply store it in disk. That's it. Or if I want to, it depends. Like I can store it in memory, I can store it in disk. It's my wish. Okay. If I'm using something called as df.persist storage level dot memory only, if I'm giving memory only means simply it will store it in my memory only. For suppose my for consider my executor, my not executor, complete executor, my Spark pool memory has only 1 GB, but I'm reading data more than 1 GB, like 1.3, 1.4, 1.5 GB. Let us take. Okay, what it will do? First of all, if I'm using only memory means how much 1 GB is there. Till 1 GB it will compute. Okay. The rest of the 500 MB data is there, it will be there in the queue, right? And one more thing it will do, it will just keep on recomputing the data. Okay, it will not spill out my data from memory to disk if my data is getting more than my memory. Okay, if I'm using disk space is very high. Disk space is very high, everyone know. But getting, I told na, like if you want to take a book from your shelf, you need to get up and go to your shelf, search your notebook and bring it back to your desk. It will take a lot of time. Same like if you want to get the data from the disk also, same thing happens. Okay, if you are using only disk, it will take a lot of time to get your job. The thing is, memory will be saved, but it will be very slow. It will take a lot of time. These are the three main functions which are there in the persist. One is memory and disk. One is memory only. Other one is disk only. These are the three things. Okay. Now, when you do not need to use the cache or persist, when you do not need to use. For suppose, if you are using any filter operation only for once you need that filter operation, and you do not need to you are not using that filter again and again in your notebook. Okay, you are not using that filter data frame for again and again in your notebook. You are using only for once. If you are only using for one, no need to do cache because it's waste of your storage memory. Just do recomputation and leave that. Just computation and leave. Okay. And if you are having huge data with low memory, then also do not cache your data, which causes spill and OMM. In executors also we are having out of memory alert. Okay, out of memory error will be there. Executor out of memory. Okay. Now there is something called as unpersist. We'll discuss that executor out of memory in sometime. Okay. There is something called as unpersist. What is this unpersist? If I give df dot unpersist, okay, unpersisting means simply it goes data from memory, or if you have stored it in disk, it removes the data from there. Okay, if you are not using some, for suppose if you came to the end of your notebook, okay, till there you have cached your data or you have persisted your data. Persistence means nothing. As I told, you can control your storage level. Either you can store it in memory or either you can store it in disk. That depends up, completely depends upon you. Okay. If you are using unpersisting, if I give df of, for suppose if I am giving some data frame df dot unpersist, if you came to end of your notebook, okay, and you do not need the data furtherly in your storage memory and all, simply you will do df dot unpersist. It's a better option to do. Why? Because it clears the data from your memory. Your storage memory will be saved. Okay, consider if I have done caching, and if I cache the data instead of doing recomputing all the times, after that I have you df dot count. So what if I am doing df dot count, what will happen? Because I have done caching, it will go to my memory and read my file from there. Done. But recomputation is not happened. But the problem over here is, if because of doing caching over here, my storage memory is getting full. Okay, my executor memory is fine, but storage memory is getting full. So what not getting full, but it takes memory. Now it's waste of keeping those unnecessary things and all, right? If I do df dot unpersist now, it just free the memory. That's it. Once notebook is done, I'm just do df dot data frame of unpersist. Simply it frees over there. Simply, this is what a one more representation of it. First of all the transformations I need to apply, and do not do caching for each and every step. Okay. For suppose if you have read one file, you have done some filterings and all, you perform all the required things and then do caching. Once you read the file, you perform caching. After some one more, again also your storage memory will go. First of all, you do whatever the operations, most amount of operations you want to declare. And for suppose till filter, after filter, you will use that filter again and again and again and again. There you applied caching. After that, use that cached data again and again. Okay. This then I have done caching and persisting. Okay. Then what it will do? It will first of all, first action, it will compute and store the data. Next actions, what it will do? It will reuse it. Once I have given the unpersistence means it will go and free my memory from the storage memory. That's it. Okay. Now come down. What are the most common mistakes that people will do in this means simply they used to cache the data before the filter operation only. If you are not applying filter, if you are not filtering the data and you before filter performing filters and all, why you need to do the caching and all? You can read the file directly, na? So why you want to filter, apply filters and all? So many people will do like that only, and at the end they want they forgot to unpersist the data. So because of that, the memory leak will happen. This thing will discuss. Okay, what is memory leak, what is spill and all. Simply memory leak means spilling, data spill. Okay. Over caching, I told na, doing caching for each and every step also will not help. Where the uh, not executor memory, storage memory, storage storage executor memory will get full. Yeah. Okay. So this is what the definition for caching and persisting. So now I want to write about it. Okay. Caching means caching in Spark stores intermediate results. Intermediate results mean filter is an intermediate result. It's not my complete result, right? It's my intermediate result, and I will use this data frame or intermediate data frame for my further operations again and again. So that's why this intermediate results, it will store in a memory to avoid recomputation across the multiple actions. That's it. Persistence is the extent of caching by allowing different storage locations, two storage locations only, disk and as well as memory. That's it. Okay, as memory and disk. Okay, and both are lazy. These both are lazy and only materialized after you give the action command. If you give df.cache, also nothing will happen. If you give any action commands like count, display or anything, then only it will perform caching. Till then, it will just add all the things your what we call it as logical plans and all. It will prepare those things. I told now that it will filter those what we call it as into cost model finally, and it will give. So it will be like that. Till then, it will not get cached. Okay. Most commonly in persistence, we use memory and disk. That's it. Because if you are using persistence means you need to use memory and disk. Why? If you want to use only memory and all, why? It's not required. You can use caching only directly. Okay. This thing I have already told. This is a memory. This is the disk permanent store. So persistence caching means I can store it in memory only. Persistence means I can decide whether I can store over here or store in disk. And as I told, the Databricks or Spark, first of all, gets your data from the disk to memory, and from memory, the Databricks can read. See, I told now there is no connector. I told there is some access connector is there between Databricks and this particular data lake, but Databricks can't go read directly from the data lake. Okay, it will get data to memory first, and from memory only it will read. That's it. Okay. You need to understand this. What is a disk? Disk is a permanent storage. This thing also I have discussed, which is my CSV files, so JSON files, so Parquet files and all. This thing also I have discussed in my beginning of the class. But once everything happened, but where cache data comes? That is what the major question, right? If my ADLS is there, all this there, but where my cache data comes? That is a major question. See, when I have read my data, read table, and after reading the table, I have performed caching on it. And after that, I have done df.count, which is an action command. Okay. First of all, what it will do, Spark reads the data from the data lake. If my data is there from the data lake, first of all, it tries to read from the data lake. and second it will store it in the executor's memory. Okay, see, if I have done caching, it will first of all from data lake disk, it will load the data and it will perform caching to a memory executor. Okay, for suppose if I haven't done caching, what it will do, if it is reading from directly from data lake only, because instead of reading from the memory, it needs to fetch from data lake first. Whatever the data frame I write, it tries to read from data lake, it tries to compute it. Okay, and it will be very slow, because I told if you are reading from disk, it will take very slow. Now comes to our major concept, which is unified memory management. What is this unified memory management? As I told, after Spark 2 plus, we can control our executors memory and as well as our storage memory, which is 50-50 percentage it will take. Okay, what happens over here is, see, we are using executors memory for joins, group bys, and all the other transformations. Whatever the transformations we are using, all that short-term memory will be stored in the executors memory. We use storage memory to store cached and persistence data. I hope you understood about the caching and persisting right now. Okay, so this entire side is storage memory and this side is for the executor memory. Okay, now consider how this unified memory management means, how it works actually, how it works on two-side basis. Okay, this is the most important thing you need to understand. Consider first of all, let us take the scenario one. Okay, what is the scenario one? Consider my okay, this is my executor memory which is in red. Oh, do not take red color because already it is there in red color. Let us take some odd colors. Okay, this is my executor memory. Okay, where I'm having huge amount of transformations and all. So because of this, my executor memory got full. Okay, it got full. It completes its 50 percentage. And let us take blue color, which is my stored memory, where these are the two that I have cached it. Okay, these are the two. These are the cached memory that I have done something called as df dot cache cached memory. Okay, and there is lot of memory is there in between, which is a very free memory for it. Okay, lot of amount of memory is there. What this will make, this will move a bit over here and it will say unified memory management way. It will say, boss, there is lot of free space in their storage memory and you can use it. Okay, what it will do, it will use this memory also. Okay, use this memory also. For suppose, okay, fine, this is also done completely, it has used it. And executor memory needs more memory. We are getting more number of transformations, more number of intermediate results we are getting. Executor needs to store a lot of memory. At that time what it will do, at that time what it will do, it will simply, what it will do means, it will say two things: either increase your executor memory or increase your total memory, you will get some extra amount. But not, that's not the better thing. First of all, what it will do, it will evict, okay, what it will do, it will evict these two cache data. Okay, it will try to evict. There is something called as LRU method is there. LRU, how it will evict means LRU method, which is also called as least used cache data. Least used cache data. What is this least used cache data means? See, if I am, for suppose, if I am not using this data again and again in my data frames, I have used this only for two. The other I have used for 6 times. Okay, same data frame I have used for 6 times to do transformations and all. What it will do, see, this has done 2 times only. We'll do one thing, we'll remove this one. Okay, it will vacate this one and allocates this memory to the executor. Okay, by using LRU method, which is least used cache data method, it will vacate it. Okay, here the most important thing is the executor memory has power or authority to evict storage memory from here. Okay, executor memory has power to have a storage memory, which is cache data. Okay, because it is prioritized to perform our transformations first instead of storing our cache data and all. It is very important to run our notebook. Most of our notebook consists of transformations only, because if it needs to run transformations, it needs to evict and it needs to sit at that place. Okay, so if our storage memory is full, now scenario 2, if our storage memory is full, let us remove everything. Okay, my transformations are very little. If your storage memory is full means you have done caching or persisting for every line and all like that. Okay, consider, because we need to discuss all the combinations. If my storage memory is full and my transformations memory is very less, will it have authority to take the executor's memory? Yes, it have, absolutely it have authority to take. See, it will take, it will take, it will take, it will take, it will take. Okay, if storage memory needs more amount of space, will it have to take the, already it has taken all the empty spaces. Will it have authority to take the this transformation executor memory which has occupied? No. Executor storage memory have no authority to take the executor already the spaces which got allocated to the executor memory. Why? Because those are only the transformations that you have done. Transformations is our first priority. You can't take it. Okay, but storage memory needs extra space. What it will do? Again, it will use something called as LRU method only. Okay, but I told now, but it has no right to take the occupied executor memory spaces. What it will do? Same, it will use the LRU method only, and it will evict its own spaces. See what it will evict its own spaces which are least used. It will evict its own spaces, and it will take its own memory again. If I haven't used the cache data much and all, those cache data it will remove, it will evict it. Only you need to understand only one thing in unified memory is that executor memory has a full authority to occupy the storage memory, empty spaces, storage memory, empty spaces. And if the if the executor memory is needed more amount of memory, then it have authority to evict the storage memory cache data or something. It will just remove which are least used. That's it, by using LRU method. But storage memory also having authority to take the executor's memory in the empty spaces out of it, but it has no right to remove the what we call it as occupied spaces of the executor memory. It needs to evict its own least used storage memory, and it needs to go. That is what the major concept of unified memory management, which is also called as Spark pool fraction, that we have discussed. Okay, now coming to the next concept, which is the executor OMM. How we have discussed about the driver out of memory, executor out of memory is also very important. And in this we are going to discuss about two major problems, which is data skew and as well as spilling. Spilling is not a problem, it's a concept. Okay, now first of all, consider this is what the data I'm having. Okay, consider this is what the data I'm having. In this data I'm having Rohit, this department ID 10 Rohit, Tushar, Shiva, some people are there. Only here I'm having only written three departments, but fourth department is also there, which is 40 department, which I haven't write it. Okay. Or let me write it for you. Okay. Because you guys will say, oh, Rohit, why didn't you write that? Okay. 40, something called as Naresh. Okay. Okay. So many people are there in 40 also. Okay. Now, what will happen if I have done any group by with respect to my department ID, and if I do dot count, okay, group by df dot group by, and if I have done count, what will happen? First of all, here my partition size is around 10 GB. 10. See, not size of, sorry, not 10 GB. Here if you observe one small thing, there are so many people are there which belongs to department id 10, department id 20 also there, 30 people are also there, but if you have seen it, department id 10, so many people are there. Okay. Now, just we'll discuss about the problem, but just try to understand this department ID 10 is having around 1.2 GB. And as when you have done any Y transformations, it will do something called as hash key and all, and it will give one hash value for you, and based on that hash value only it will decide your partition id, and it will do hash key mod of 200 partitions, and it will give one partition id, and how many people will get the same partition, all the same people will go to same partition like that. I told na, means the same partition ID or the same hash key will all the people will reside in the same partition. By how? With the help of shuffling. If you have watched my previous videos in Y transformations, narrow transformations, you will get this point. Now, if so many people are there which belongs to department ID 10, all these people will go to one partition only. Simple sorted. Okay, this is, so let us continue with the executor out of memory. Okay, as I have told that we are having out of memory, as we are having for driver out of memory, we are having executor out of memory also, but here two concepts will get included. One is data spill, and the other one is data skewness. Okay, what is data spill and data skewness, we'll get to know in some time. Okay, so as I have explained, this is our data, and you need to remember one thing, that there are so many people are there which belongs to department id 10, which crossed almost all 1.2 GB. Okay, what our actually what our executor will do, this is my disk. Okay, this is my disk. I forgot to write, this is my disk. This is my disk. Okay, and this is my what, this is my memory. Which memory? Executor memory. Executor memory. Okay, so now the problem over here is, consider in initially, okay, initially let us leave about department id 10. For some time leave about, I don't have any department id 10. I'm having departments from 20, 30, and as well as 40. Three departments are there, right? In these three departments, 20, 30, and 40, the 20 department is having 300 MB, means that partition size. As I told, all when you perform any white transformations of group by and all the people who belongs to same department, or all the people who belongs to the same partition id will go to the that partition id. So all the department id 20 will go to the second partition, something called as like that. All the department id 30 will go to one partition, all the department id 40 will go to one partition. Okay, consider the out of a department ID partition only consists of 300 MB. and department 30 consists of 40, department 40 consists of this one. Okay, so initially what it will do means, what Spark does internally means, see, consider your executor is having 1 GB of total memory, 1 GB of total memory. So if you are loading your file, first of all it will load 200 MB, 300 MB over here. Okay, that good. So initially, do not take like your department of what we call it as your department 10 has 1 GB like that. Okay, before that, let us take your department ID 10 has only 300 MB. Let us take like that. Okay, so your department ID 10 have only 300 MB. Let us take. So what it will do, it will first of all try to load department ID. It will take this partition will be taken by 10, which has 300 MB. So out of 1 GB, 300 MB completed, 700 MB left. Now comes to the role of department ID 20. Okay, department ID 20 also, this one 300 MB taken, total 600 MB gone, 400 MB left. Now, now comes to the out of 600 MB. Okay, if my department ID 30 loads which have 300 MB. Okay, let us take our department this one also 300 MB only. Okay, let us take 300 MB only. So you'll confusion gets clear. So this will also get taken. So my executor memory is currently 900 MB. Okay, it is currently there at 900 MB. Okay, so how much amount of MB has left? 100 MB is free space, and this 900 MB is occupied or full. Now, now I need to bring my department ID 40, which has also 300 MB. See, what Spark will do, Spark will apply something called as data spill. Data spilling means spilling of data to my disk. Okay, what it will do means simply, it will not take the what we call it as 100 MB partition. Okay, it will fill 40 MB like that. No, it will not do like that. What it will do, it will not spill out of 40, it will spill 30. What it will do na, it will first of all choose 30, 20 or some random partition. It will what we call it as occupy the space, or it will spill that particular partition to my disk. Okay, it will spill my partition to my disk, and that space will be occupied by my 40. My 40 will not go. Okay, my 40 will be there in memory only, but already whatever the existing partitions are there, out of those existing partitions, one partition will get spill out to my disk. One of the most important thing that you need to remember is, like, I'm having 100 what MB free space, so I will just spill out 200 MB from the 30th department. No, either you need to push the entire partition to disk, or either you need to keep the entire partition in one place. You can't again divide your partition because it's already been partitioned. How much you will do again? No, either you need to push an entire thing. Now if I push my 30th department ID to this particular disk, how much amount of space will be there? Only 300 MB, 300 MB, 600 MB. Total amount of 400 MB will be there. Within that 400 MB, my 40th department ID will sit. This is what how data spilling happens. Okay. Now what is data skewness? Data skewness means, consider my department ID 10 people are going rapidly and they have reached out to almost all 1.2 GB. Okay, you can say that, Rohit, why we are getting that OMM? You have told na, like executor out of memory. So every time I'm getting the data over here, no issue. It will get spilled out to my disk. my disk is having lot of space, nothing will happen. Again, obviously disk will have ample amount of space. You keep on loading because all the data will be there in disk only. You will just fetch to memory and you will read whenever any file you want to read. That's it. You will not read the entire data, no? That's it. Consider disk is your what we call it as your water tank which is there in your home. Memory is the bucket. So how much amount of water you need in the bucket, that much amount of water you will take and you will go. That's it. You will not need to take the entire water which is there in the tank, right? So that is what the major thing. Okay. Now when you come over here, my you can say why we'll get OMM alert and all, because every time if my partition size is getting if my data is getting increased, and if my uh, any partition which is coming more than my executor memory also, my executor is simply spilling my data to my disk. Why I'm getting? Yes, you're right, but one small thing is there. As I told, when you perform any Y transformations, all the transformations which belongs to one department or will belongs to one group will go to one partition only. So consider my department ID 10 people has gone. So much amount of people which go into department ID 10. So it had took about 1.2 GB as a single partition only. Okay. Now, first of all, my executor memory is 1 GB, and the partition which is taking over there is almost all 1.2 GB. If it spills any partitions to disk also, what is the use? Why? Because my total executor memory is 1 GB and I'm giving one partition size which is almost all 1.2 GB. So then we'll get OMM alert, which is also we call it as a data skewness. So what is data skewness means? When executor couldn't able to handle the amount of data which is greater than the what we call it as its memory size, at that time we'll get causes something called as data skewness. Okay, and what is a fix for that? The fix is a second. Hello. Okay, so this is what data skewness. Okay, whenever our executor memory, not executor memory, whenever our partition size crosses my executor memory, at the time I'll get this data skewness. Okay, now these I have explained in detail what is the data skewness and all. If data is unevenly distributing, oh, spelling mistakes, distributing. Okay. Yeah. So whenever my data is distributing uneven across the partitions, so at that time I'll get the data skewness. It's not uneven. One more thing. If I'm getting executor out of memory or driver out of memory, it's not the problem with the Spark. Okay, it's a problem with the data only that we are giving. Okay, if my data partition is rapidly it is getting increased, means what I can do? Okay, we can't do anything. Like why I'll get data skewness means, as I have told, some partitions will have heavy data, some partitions are almost empty. Some, because out of 200 partitions, if you see, hardly it will use 4 to 5 partitions only. Within 4 to 5 partition, one partition, if my data is having more than 1 GB and all, not 1 GB, my executor memory will be very high only. Almost all 16 GB like that will take each executor memory. And companies, they will take 32, 64, more than that also they will take. Okay, it depends upon their size. Now, now what will happen over here is, if my, and out of 200 partitions, it will not take all the partitions, it will only take one partitions, which will be what we call it as take my entire data. So which causes skewness for me. Okay, which, because of that heavy data, which causes slow jobs. And one more thing, if for suppose if some of my partitions, if I am having, let us take 4 partitions. Okay, Let us take four partitions. Okay, two part and three partitions having light data. Okay, means I'm having light data means like light data means which I'm having IDs for department ID, what we call it as 2, 3, and 4 for three these departments. And my one partition I'm having heavy data. Heavy data means which partition department ID 10. Okay, for department ID 20, 30, 40 light data. And do not think like this only heavy data will take some time and it will get executed. Meanwhile, these results will got executed and it will provide data for you. No. Spark job will get completed until and unless all the tasks will get completed within it. Till all the tasks are not completed, it will not give you the result. Even one task get failure also, it will throw an error for you. That is what the Sparks principle. Okay. So do not think like the three partitions, department ID 20, 30, 40 partitions will get executed and those partitions data I'll get. Only the 10 data will be skipped. No, not like that. It will wait and the job will wait until the last one, even one partition is there to complete that till one task is there to complete till that it will wait. And if my one partition 10 department ID 10 partition is taking a lot of time, it will wait for that. Because of that I'll get the slow processing out of it. Okay, now so before going into that, let me start my cluster because it will take some time to start to show you some examples on top of it. Okay, now as I have told, uh, as I have told, when data is unevenly distributed, it causes skewness and all like. And what are the symptoms for that? For causing the data skewness. Okay. The major symptoms to cause the data skewness is because of joins, group bys, aggregations, repartitioning on the bad columns. This is the main symptoms. Why? If you do joins, so many tables will have the other table will have lot of records on a particular department. Both the tables will get joined and it will do shufflings, repartitionings, all these things and all. It will go. That's simple. It will one partition it will take entire data. The one partition, if it that partition is having more than the what we call it as GB than this executor memory, that's it. Boom. Group bys, just we have taken example for group bys only. Same joins and group bys, joins, group bys, aggregations, all these are y transformations only. If you perform any y transformation wrongly, then it will go. And what are the techniques to resolve this? First of all, broadcast join. Okay. If you are having other table is a smaller table or a medium, smaller table means not in MBs like that. Okay. If your executor memory is having 16 GB. Okay. If your smaller table is having at least 1 GB, try to do broadcast join. This is very easy to do. Okay, this is how you handle the big data. Okay, that's why Spark is a master to handle the big data tools and all. Okay, now second thing, increase the number of partitions. If 200 partitions, see in industries now, 200 partitions also sometimes it is not enough. So what they will do, they will increase the partition size. Okay, and increase the executor's memory. This is temporary fix only. Why? Because how long, if without controlling your data and all, how long you keep on increasing the executor's memory? No. Okay, better to use better key. Okay, what is cardinality means? Avoid low cardinality columns means what? uh, Cardinality means if same kind of column, same kind of values are getting repeated for so many times, that is what we call as cardinality. Okay, so better not to do joins or better not to do group bys on the columns which have low cardinality things. That's it. Okay, now in this one data skewness, we are going to discuss, you know about the broadcast joins, you know about how to increase the number of partitions and all. Okay, and you can set the number of partitions defaultly also. And what we call it as we'll discuss about the sort this one executor memory. This you can do by going to compute and all. And this one, it's actually this is not at all that much possible. If you are having requirement, you need to do, but you need to manage the other things. That's it. Okay. We'll discuss about the salting technique. What is a salting technique? This is also an optimization. Okay. See, lot of optimizations we have already covered in the past three videos. Okay. Like what we call it as how to recover this caching, persistence, and as well as this repartitioning. Repartitioning is also we call it as a what partition pruning. If you are doing partition means splitting your data will will help to your executor to read it fastly. Okay, partition pruning, salting techniques. So executor how to fix the, see if you are providing any fixed to anything, so that's a optimized thing only. Okay, and what is the salt technique? Salting means this is a real time salting technique which is used by Spark. This is what the definition, okay? To handle the data skewness by adding an additional column. We'll add one more additional column which is called as salt, okay? And within this column, we'll add the random values to the heavily repeated key, okay? We will add random values to the heavily repeated key. In our case, which is department ID 10. And once we add one more extra, nothing, we add one more new column and we give random values to all the keys. And majorly sometimes we will give only for this particular data only. Sometimes we will give for all the values. Most of the times we'll give to all the provided values. Okay, what we will go, and we will give some random values to the heavily repeated key so that the data is distributed across the multiple partition instead of going to single partition. How it works, how data will not go to single partition, how it get distributed to a multiple partition. So let us see. What first of all I'll do, first of all I'll do from pyspark.sql.functions import rand floor. Something rand means random number, okay? Floor means to distribute, to give the random numbers to those things, okay? This is one of the function that we use in pyspark, okay? And this function also I'll discuss in PySpark video, okay, the coming up videos. But first of all, you try to understand PySpark, what it goes in backend and all, then the coding part will be very easy for you, okay? And some people, first of all, they will learn coding part and then come to these concepts, and it is much more easier for them to understand these concepts, okay? Now I'll create one new data frame. This is with column. Df dot with column means if you want to add any new column in your data frame, you use something called as with column. What is a column name that you want to add? Because before I'm having only department ID and student name only. I want to add or create one new column. So that's why I'll do df dot with column. I'll give salt. The column name I want to provide is salt. And what I'm going to do in this, first of all, I'm going to provide floor and rand of star 3. If I give like that means rand of star 3 means it starts from 0, 0, 1, 2, 3. These are the three values, and these three values it will distribute toward the all the rows like in its own manner. That's it. Apart from that, nothing will go. So in that manner, what is the use of if by doing like that means, see, when I am applying group by, okay, to group by transformations, I not only apply on department ID, I will do group by with respect to department ID and as well as this salt column. So in that case, what will happen? The department ID of 10 and as well as salt column of 1, how many people are there? All the people will go to one partition. Example, see this Rohit and as well as this Divya. These two people will go to one partition. Okay, and this Nagesh is there, which is from the department 10 only. But when I apply group by on department ID and sort, it will take both in consideration, right? So department id, it needs to first of all check he is from department id, and it needs to check he is belongs to salt column of 0 also. So these two people get grouped by, and these two people will send to another partition. Y transformation example only. Okay, like that the data gets filled. This is what the major example of this salting. See how it got splitted. See this group by with salt, if I have done, I need to do group by with respect to department id as well as salt column. If I have done count, what will happen now? Sorry, I have wrote it in Telugu now. Now, oh, partition will not be there in single column. That's it. Okay. Now, now partitions. How partitions will go? Now department ID 10, salt column 0 will go to one partition. Department ID 10, salt column will 1 will go to one partition. Department ID 10, salt column 2 will go to one partition. Okay. Partition will be there in a single column only. Okay. So the memory will be saved, and data spilling also happens safely. Data spilling will happen because each partition is not calculating like that. So this is my final calculation which I'm doing partial by group by and all. So what will happen? I'll get my data safely. So before what happens? Department ID 10, which has only one partition, taking more than my memory causes OMM. After solving department ID of 10, department 10 got splitted into three partitions because of the salt column, and it's a safe. Happily it will go. This is what the technique of salting. Okay. So let me go to my Spark, which got completed or not. Still loading. Yeah, it completed. So let me go to my recents, because recently I'll open my notebook. Let me open another notebook. So copy this one. Okay. So I have opened one more new notebook. So is my now my cluster is also fine. So let me copy my this. Let me turn off my AQE, and as well as let me read my std file. Okay, let me read my std file. So till here it's fine. So if I read it, it's fine. So I'm reading my file from the data lake and all. Okay, it is good. First of all, let me go to my data lake, resource groups, and this one. Open the storage account, containers, containers, think in source. I'm having these two things. Yeah. So where I'm going to write my data in destination, first of all, I need to make sure no files are there in my destination. Okay. Let me delete everything. Okay. Because this is 2 days before data, which is not required for me currently. Okay. So my data got read from my source, which is a student table. Right. This is my student table where my data got read. Fine. Now let me display my data. What my data is having. df dot display. See, first of all, I am not going to show any kind of executor out of memory because I don't have that much data to crash my memory and all. Okay. Second thing, it is not that much good thing to do also. Okay. But you need to understand when the executor memory will get and what kind of precautions you need to take. So these are the people I'm having, the student name, all these things and all. See, if I for suppose if I have applied, see, for your basic understanding, if I want to, or let us not read this data. Let me go to containers, source. Within the source, let me upload one file from my desktop, which is, I think, e-commerce file, I think so. What is the file name? Orders. Yeah, this one. Orders large, this one, this file. Let me open this file. Okay. Let me upload because this file is having a lot of data. And what is the file name? Orders.csv. Na? So let me change it over here. Not within the students. Only I am uploading in my container. So it is okay. Orders.csv. Okay. Let me run out. Now let me run out. So I'll get the data for my this one. Orders.csv. See, now if I have done some filtering, okay, now what I'll do, df underscore filter equal to df dot what I got filter. On top of df I'll do filter column of, not my order status. Let me check my what my data consists of. Yes, I want to get the data who has done only credit card payments. Okay. So let me check my payment method. Where it is there? Payment method equal to what I need to give. Yes, credit card. But why all these things here? So this. Okay, I have done df dot display. Okay, I have got this data. Fine. Later on, I have used this df again to do some further. Now I'm explaining about caching. Okay, caching. Now, if I want to again use this data, okay, to do further things like I want only what we call it as product category of home decor and as well as kitchen. Usually no one does it, but to do further analysis and all, I'm doing it. Okay, what I'm doing, df underscore again what we call it as some df1. This time I'm taking df1 and I am using my df underscore filter. Okay, filter. If I'm using my df underscore filter, df underscore filter dot, again I'm doing filter, and this time what I'm doing, column of what is a column, product category. Product category is equal to not baby. Okay, I have done this product category as something take as books, and let me do df underscore one dot display. Okay, df underscore one df1 dot display. Yeah, so this time I have got it right. So instead of doing this, so I have used my filter which I have already declared before, and I am using it again, right? This time simply if I want to what it is going on, simply you do df1 dot explain. Okay, you will get some what we call it as physical plan out of it, and this plan you can read it. I have read my file from my orders table. Before that, I have turned off my AQ. I told like AQ will be there. It will not do this kind of rubbish things. Okay, it will change the plan in between. So first of all, what I'll do for caching, see, I have cached my data. Okay, I didn't cache my data. Sorry, I have read my file. I applied the first filter on df underscore filter, which is for credit card payments. Then I need to use this filter for so many other things, to create so many other tables for kitchen, for home decor and all. I need to create so many tables out of this. Okay, but the message first of all thing is I need to make the huge filtering on this credit card. This kind of filtering we call it as predicate push down. Predicate push down means filtering, early filtering and all. Instead of first I go to my home decor, then doing credit cards, then again going to my kitchen, filtering by kitchen, then doing credit card. It's not the better approach. Better to do predicate push down. What is the predicate push down? If you want to do all the filterings with respect to credit cards and debit card, first of all filter it out. That is what predicate means. Pre means before. Decade. Before decade, you need to do the filtering, push down. So you need to remove unnecessary things. Then you want to apply whatever the filters you want. Okay, now you have applied filter on credit card. Okay, predicate push down is done. Come down. You have applied on this books. Now you apply on df under df dot one dot explain. If you apply df dot explain, if you are getting an option like file scan.csv. See, you are asking to explain the df1. df1 means this is a filter applied on top of your df underscore filter. But df before df underscore filter, already the file has read on in df. But it will not do. What it will do? First of all, it will again scan your CSV file, which is the data reading initial stage. Okay. Then after that, what it will do? Then it will do apply filter. This is filter. This is not null. First of all, it tries to remove all the not nulls and all. On which category? On payment method. Payment method means what? That before filter you have done on top of your credit cards and all. And once that is been removed, then after that, now the main filter on your product category. Okay. So what it is doing, first of all, it is removing the null values from your payment method and as well as product category. Then it will only select your payment method from your credit card, which already done before, but again it is doing right now, which we call it as a recomputation. Now finally it looks for books. So it will consume lot of executor memory. So to prevent this, what I will do, simply I will once, this is my main filtering now. I want to filter with respect to the all product categories and all with respect to credit card only. What I will do here, simply I will do that cache. Okay, if I run all, see my plan will get changed. If you are watching something called as uh, in-memory relation or in-memory table scan, which means that the data is cached or persisted. Okay, which data is cached or persisted. What it is doing means, see, first of all, initially at the beginning, it read my data, right? It is not reading again. Okay, it will show the entire plan. Initially it read your data, then you have applied filtering on your payment method where it is equal to credit card. Yeah, then what it has done, it has done in memory relation, which is your catching. You can see something called as storage level disk memory and decentralized one replicas, like that. See, this time after Apache Spark 2.1, catching means it will apply to both memory and as well as disk, like how persistence is been applied. Okay, but better if you are using for storage memories and all, better to apply that unpersist only, persisting only. Okay, now when come to the in-memory table scan. So when you are doing that in-memory table scan means you are simply, see, when I'm doing df underscore filter this one. Okay, it needs to again, actually what it needs to do, it needs to recompute again. Now nothing it will do. When I have done df underscore this catch now, this entire result of this entire result will be stored in my storage memory. right? So that's why when I'm doing in-memory table scan means furtherly I have again scanning my, this time this df1 is scanning my storage level where it got stored. Okay, so this thing is scanning these all columns, and it maintained not to have any nulls and all. So this is what in-memory table scan, which means instead of recomputing again, you are going to your memory and scanning the result and getting over here. That's it. Okay. Now after that, you are doing filtering over here. Simply see this time. Before, if you see before plan, before catching plan, here you got product category, product, all the things before which you have done filter, but this time you got only product category, which is books. But before, if you go, you can see the payment status also, whether it is filtered with respect to the credit card or not, that one also. But this time you can see only this one. This is what catching. Okay, same. This one persistence is also same like how. Okay, if you, sorry, if you go here and so if you go here and applied what we call it as where persistence, yeah, this one. So first of all I need to import my storage level so first what I need to do, first of all, from PySpark, okay, import storage, storage, okay, storage level. Okay, first of all you need to import the storage level. And one more thing I need to show, uh, if you do df dot display, display, okay, if you run on, you can see one DAG, DAG will come to you, right? So just go to Spark and view the DAG. Just open this one. Okay, if you open executors right now, okay, if you open executors right now, not executors, you can see in executor driver, and how much is there and all those things. No, in not in executors, you need to go to storage, I think so. Yeah, see, storage, before, if you have uncached anything, you just go over here, you can see something called as this RDD will not be shown for you. But once you have done caching or anything, this will be, is not null will be stored. So this thing will be stored in this. Okay, whatever the data that you have cached, what is the storage level, disk memory. As I told, after 2 plus Spark 2 plus version, everything is stored in this. Okay, and how much fraction scanned, 100 percentage it got scanned. Size of the memory is 10.7 and it's very small. So that's why I am telling now, that's, it was not for me to uh, what we can say, crash my memory and all. It's not happened with me. Okay, right now, for suppose I do not want to cache my data, what I need to do once I have performed everything, simply what I'll do, once I have write it into my disk or somewhere, simply what I'll do, df1 dot unpersist. Okay, simply I need to do this. And if I run it, once, for suppose I didn't write my data to my disk, okay, if I, after writing my data to my disk, simply I'll do df1 dot unpersist. What it will do, it will just unpersist my data. See, if I do this one, okay, the data was not cached with respect to df1, I think so. The data was cached with respect to df filter. Yeah, this one. Okay, let us complete that one also. Okay, now let me write my data so you'll get some real-time industry experience. Let me scroll down. Yeah, this one. Control A, Control C. First of all, after filtering my data, okay, I have cached it. I have used this for multiple times. Okay, I will not do this one after applying filtering. Even though I will not apply this DF, this one also. Simply what I will do, I will write this data to my something called as orders. Okay, I will write it over here simply. Okay, after writing, what I will do, not repart df1, df1 dot write. Okay, after writing, what I need to do, whatever the data that I have used cache df underscore filter, I will unpersist it, means I will just clear my memory. Df what is this one, df underscore filter dot unpersist. Okay, simply now see, before this is my DAG before, right? Now let me run all, let me run all. Okay, let me run all. So this got unpersist. Okay, now if I see my DAG, okay, if I see df what we call as one dot display something, or df filter dot df underscore filter dot display some action command I will do. If I have run it, now the caching or unpersistence will happen. Now if I go to my Spark jobs and view my job, if I open this one, if I go to storage, now you can't see any kind of RTD because it cleared the memory. This is what the steps that you need to take. So now my memory is also saved, because after rest of the partitions and all also, it can have this memory. This is the most common mistake that people will do, but this is what the fix that you need to provide for it. Okay. Now for unpersisting, for unpersisting, let me take a df dot this one. Okay, unpersist this one. Let me use this one for your explanation. Same persistence also same. Okay. Now what I will do, once I have done with this, okay, I have removed caching. I will remove caching, and I will just place this one, and I will do df underscore filter. Okay, df underscore filter. Just a second. Yeah. So see, if I have added like this, okay, I do not want to display this one. I'm just persisting it. Okay. So if I have ran this one, why storage level it needs to be there within this one? PySpark dot storage. Yeah, capital letters I missed it. Yeah, sorry. Indentation alga. Okay, fine. Continue. Yes. Now see. Now what I'll do? Now I'll run my entire notebook. So what I have done? I have done persistence this time. See, which I have taken memory and as well as disk. Okay. If my memory gets full, it spill outs to my disk. That's it. Okay. But I tell her I don't have that much amount of data to do. Okay. Now there is something called as df underscore filter. This also ran, this also ran, this also ran, this also ran, right? Now let me, so okay, why I haven't should not do this one right now. Okay, let me do this, and let me, after writing my data, what I will do, I will write something called as df underscore one dot explain. Okay, df1 dot explain. Okay, now let me run on. If I do df dot explain, see, same thing happen. First it scans my file, then it will do persistence. Okay, now I told catching and persisting both will do same kind of stuff. Okay, now after that, when I'm again doing filtering, it will read from my table scan, in memory table scan, from it will read my data. And now after that, what it will do, it will do filtering again on my books only. If you want, you can compare it also. It's a beautiful example. Okay, from where my data is reading in this particular area. Okay, now if I, once I have done, let me check my DAG. Okay, what I need to check, if I have checked my DAC, I can see my data got persisted. Just I need to go to my storage. See, this got it is there. If you see this one, see, only one partitions are there because I haven't applied anything. Okay, and what is the RDD block number? This one. What is my storage level? Memory only, because it tries to store in the memory. If it gets full, then it will be spilled out. So you can see size in memory is this one, size in disk, because it didn't spilled out anywhere. So this one, that's it. This is what I want to explain about all the data distribution in drivers, executors, all these things. But see, at the end, I want to not want to remain as it is. I want to, once my job gets completed, I want to unpersist my data. Simply do unpersistence. If I now view my plan, I will not see any kind of RDDs over there. Simply go see. No RDDs, nothing. Simple, boss. Sorted. This is what completely about this one. And I have told you can increase your party. There is something, one extra convenience I also have given to increase your partition size and all like that, right? See, just a second, where I have told unified memory management. No, 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 no. This is all sorting techniques. Okay, now where I have stored it. Reader. This is all my sorting techniques. Okay. Now, what broadcasting techniques and all. Where? Not executor out of memory. Where was time wasted? Need to tell this part. Okay. Yeah, see, I have told something now that you need to increase your executor, this one, or increase the number of partitions. How you will increase? Either the simple trick that you will simply you will use that repartition your data, like df dot repartition to 10. This is what simple partition. Or if you want to increase your what we can say, if you want to increase your shuffle data partitions, like if you are not enough with your 200 partitions which are there, so that one also you can do. Okay, or second thing, you can control by using your shuffle data part. How you can do? Simply do spark.conf. Simply do spark.conf dot set. What you need to do? Simply do spark dot sql dot shuffle dot partitions. If it is there for 200, you can use for 200. If it is not enough, you just, if you give 500, your partitions will get 500. That's it. So apart from that, this is what completely about Spark, complete guide about Spark. Only two things were left, which is AQE, adaptive query executions, and Spark optimizations. One more thing, I have covered almost all the Spark optimizations till now, how you can do all those things and all. But just I want to make one 30 minutes or 40 minutes video on top of it. I can cover in this video, but already my video has took almost all 3 hours time, so it will not support to give you. So just next 30 minutes video you will get, that's it. Okay, that 30 minutes video you see, and in that I'll cover what are the PySpark questions that will be asked in your interviews also. Okay, so that's a great video, watch it. And it is a final part. Okay, so if you are clear in till now also, if you are clear till now also, 99% Spark questions you can answer. Okay, just for the next video, two concepts left, that is small concepts. With that I will share the Spark questions also, what are questions that will be asked. So thank you for today. Thank you.